disconnect is required for a portable generator. The National Electrical Code, specifically Section 445.10d in the 2023 edition, addresses this requirement. This section states that where a building or structure is supplied by a portable generator, a suitable disconnecting means shall be provided at the building or structure for disconnecting the generator from all live conductors of the electrical system. A portable generator is considered an external power source. It must be disconnected from the electrical system before connecting it to the transfer switch. This disconnect is required to ensure the safety of electrical workers and to prevent backfeeding into the utility grid. To comply with the code, you must install a disconnect switch at the building or structure where the portable generator will be connected. Ensure that the disconnect is rated for the amperage and voltage of the generator. Mark the disconnect clearly to indicate its purpose and the generator it serves. The disconnect should be located in a weather-protected area and easily accessible for operation. The disconnect should be interlocked with the transfer switch to prevent accidental energization of the generator while the utility power is still connected. The owner should be instructed on the proper connection and disconnection procedures for the portable generator. Let's delve deeper into the reasoning and practical application of these requirements. The primary reason for needing a disconnect is safety. Firstly, it protects electrical workers from potential hazards. When a portable generator is connected to a building's electrical system without a proper disconnect, there's a risk of backfeeding electricity onto the utility grid. This backfeeding can energize lines that are supposed to be de-energized during maintenance or repairs, posing a significant risk of electric shock to utility workers. Secondly, the disconnect prevents damage to equipment. Without a disconnect, the generator's power could conflict with the utility power when both are present, potentially damaging the generator, the building's electrical system, or even the utility's equipment. Thirdly, the disconnect allows for isolation of the generator. During maintenance or repairs of the generator itself, the disconnect ensures that the building's electrical system is isolated from the generator, preventing accidental energization. From a practical standpoint, installing a disconnect switch is relatively straightforward. The switch should be rated for the maximum current and voltage that the generator can supply. It should be installed in a readily accessible location, preferably near where the generator is connected to the building's electrical system. The disconnect needs to be clearly labeled so that anyone working on the system knows its purpose. When selecting a disconnect switch, several factors should be considered. Firstly, the amperage rating. The switch must be rated to handle the full load current of the generator. Secondly, the voltage rating. The switch must be rated for the voltage supplied by the generator, typically 120/240 volts for single-phase generators or 208 or 480 volts for three-phase generators. Thirdly, the environmental conditions. If the switch is located outdoors, it must be rated for outdoor use and protected from the elements. Fourthly, the type of switch. There are various types of disconnect switches available, including fused and non-fused switches. A fused switch provides additional protection against overcurrents. In addition to the disconnect switch, it's also crucial to have a properly installed transfer switch. A transfer switch allows you to safely switch between the utility power and the generator power without the risk of backfeeding. The transfer switch should be interlocked with the disconnect switch to prevent accidental energization of the generator while the utility power is still connected. The installation of a transfer switch typically involves several steps. Firstly, select the appropriate transfer switch. Choose a transfer switch that is rated for the full load current and voltage of the building's electrical system and the generator. Secondly, install the transfer switch. Mount the transfer switch in a suitable location, typically near the main electrical panel. Thirdly, wire the transfer switch. Connect the utility power, the generator power, and the building's electrical system to the transfer switch according to the manufacturer's instructions. Fourthly, test the transfer switch. Verify that the transfer switch is functioning correctly and that it safely switches between the utility power and the generator power. Regular maintenance of the disconnect switch and transfer switch is also essential. Inspect the disconnect switch and transfer switch regularly for any signs of damage or wear. Test the operation of the disconnect switch and transfer switch periodically to ensure that they are functioning correctly. If any problems are found, have them repaired by a qualified electrician. The National Electrical Code, or NEC, is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect the latest advancements in technology and safety practices. Compliance with the NEC is essential to ensure the safety of electrical workers and the public. Several other sections of the NEC may also be relevant when installing a portable generator system. NEC Section 250.34 covers the grounding requirements for portable generators. It specifies how the generator should be grounded to ensure safety. NEC Section 700 covers emergency systems, which may include portable generators used to provide backup power during power outages. It outlines the requirements for the installation and operation of emergency generator systems. NEC Section 701 covers legally required standby systems, which are systems that are required by law to provide backup power. It outlines the requirements for the installation and operation of legally required standby generator systems. Understanding the NEC and adhering to its requirements is crucial for anyone involved in the installation or maintenance of electrical systems. Proper training and certification are essential for electricians and other electrical professionals. Several organizations offer training and certification programs for electrical professionals. The National Fire Protection Association, or NFPA, offers a variety of training programs on the NEC and other electrical safety topics. The International Association of Electrical Inspectors, or IE, offers certification programs for electrical inspectors. The Independent Electrical Contractors, or IEC, offers apprenticeship programs for aspiring electricians. Continuing education is also essential for electrical professionals to stay up to date on the latest codes and technologies. The NEC is constantly evolving, so it's important to stay informed about the latest changes. Several resources are available to help electrical professionals stay up to date on the NEC. The NFPA publishes the NEC and offers a variety of resources to help understand and apply its requirements. The IE offers educational programs and resources for electrical inspectors. Electrical trade publications and websites provide articles and information on the NEC and other electrical topics. In summary, installing a disconnect switch for a portable generator is a critical safety requirement. It protects electrical workers, prevents backfeeding, and allows for isolation of the generator. Compliance with the NEC and proper installation practices are essential to ensure the safe operation of portable generator systems. Remember to consult with a qualified electrician to ensure that your installation meets all applicable codes and standards. This will ensure the safety of your electrical system and those who work on it.